I'm Matt. I'm a senior engineer here at Skyscanner. I'm a member of the data tribe, so we look after all things data. And specifically, I'm in the theft squad, who look after the financial data. And then prior to that, I was at the BBC, where I was a lead engineer on the iPlayer back-end team. And if you wind the clocks back far enough, to a time where I had more hair and no idea what I wanted to do in my life, I was doing a PhD. But anyway, I've traded my hair for a sense of direction, and here I am. So I'll be talking about moving fast and slow. Like, it's a slight change to the title than one published, but the content's pretty much the same. I'll be talking about what it means to move fast, some of the techniques we can use to help us move fast, and what happens if we move slow. I'll be touching on examples from my experience, and hopefully there'll be something of interest for you guys you can take home later. But first, you know it's going to be a good talk when it starts with an apology. And I've been fighting with this presentation for about 2 weeks, and I got to a point where I was happy with it. And then I checked what the topic was, and it was performance. And for some reason, I didn't know that, which is really frustrating because I've got so much to say about performance, especially around Node.js, having built iPlayer backend using Node. So a bit gutted there. I'm hoping that there's some stuff interested. I've tried to shoehorn some performance-related stuff in here. I hope it hasn't made it too incoherent. So anyway, so moving fast. So what do we mean by moving fast? I think moving fast is the ability to develop features and deliver them to customers in a short period of time. It's pretty obvious, really. But why do people strive to move fast? What are the benefits? I think for the business, you can realize potential revenue streams quickly. You can maintain a competitive edge. Like if you're moving quickly, you keep your competitors at arm's length. And you learn faster. Like you get your feature out, you can measure the impact of that feature, and you can evolve and innovate. But also for developers, I think moving fast, you get feedback quicker. That might be from product owners, it might be from customers directly. There's a sense of achievement. You know, you're building something and you're releasing it. If you work on the same thing for a long period of time, I'm fairly sure a lot of you here would have experienced that. It gets quite frustrating. And also there's less downtime. If you're building and releasing stuff quickly and iterating, then you're not sort of wasting time on legacy systems and things like that. A couple of examples of how moving fast might impact a business. I think reacting to major events is one of them. I think here at Skyscanner is a really good example, which is if there's any major events in a city somewhere, they will very quickly shut down advertising on that city because we don't want to be associated with advertising cheap flights to a place which might have just witnessed a tragic event. And also being first to market on new technologies is constant innovation in the tech industry. Things like Alexa, Google Home, ARKit, which is one of them. And if you can get there first, there's a kind of there's a hype train you can sort of ride, and like if you're one of the first adopters of these technologies, you can gain a bit of free marketing on the back of it. And ARKit is something that we're looking at, so watch this space. And then moving slow, like if you're not moving quickly, what are the implications of moving slowly? You know, you can lose out on revenue. I think if you're taking a longer period of time to develop a feature and you're not getting it out to the market, you're not making revenue, you're not making money, so you're missing out there. It can be brand damaging. I've got some examples later where not being able to react to incidents quickly can be brand damaging, and obviously that costs you money. And for developers, it can be frustrating. Like I said before, like if you are working on the same feature for a long time and you're not making progress, it's frustrating. People tend to complain about legacy systems or things like this, but like basically it's a symptom of not being able to iterate quickly on a piece of software and release it. So some examples. One example would be lacking confidence to change a service. I'm fairly sure a lot of you would have worked on a service where, but maybe there aren't tests, maybe there's some tests, but you have no confidence in it. Maybe the release process is long-winded and it's not automated. And people get a bit edgy about releasing it. So like people don't want to change it, people don't want to release it, and like, oh, we shouldn't release it on a Friday or along these lines. And that can really impact you. And at the BBC, there was a service, an API that got to such a state that no one dared change it. Everyone in the BBC was using it. No one dared change it. No one dared release it. And in the end, it blew up. And I think it was a period of downtime for 2 days, like the whole weekend. BBC was down, which is terrible. Ironically, that service was called Dynamite. It's now gone. And also, infrastructure is unable to scale. Like nowadays, with the cloud, you might think that doesn't happen anymore. But last year, I was working at a company, and every weekend they would have a major event. And one weekend they fell over because performance issues. And the next weekend, they were unable to scale their infrastructure because, and this is deadly serious, a server was stuck in customs at Heathrow. So like, that had a genuine impact on that company because they were unable to move quickly and resolve problems. But don't just take my word for it. I think Mark Zuckerberg once said, move fast and break things. Unless you're breaking stuff, you're moving fast enough. Great advice, something that really struck a chord with me, and I tried to live by it until, So we had an incident with iPlayer. This is at the time when I was the lead for the back-end team, and this was solely my team's responsibility. So I'm not sure Facebook had a revenue stream when Mark was saying, yeah, let's break things. I think it might be slightly different now. I think he's probably chilled out a bit. Dealing with this level of fallout is not fun. So I wouldn't really recommend that. I have to say that was probably one of the worst weeks of my life, trying to deal with that issue, because the thing about iPlayer is people aren't going to go away. They're going to keep coming back, and every evening you're going to hit a peak of traffic, and it's going to be very difficult to, if you haven't fixed the problem, to last the night. That particular incident was performance related. And as I said before, if I'd known this was meant to be about performance, I would have told you about everything you need to know. But unfortunately, that's not the case. So, now moving fast is easy. I could start hacking on an Express API now and probably knock something out and be like, yay, I've developed an API. But obviously what happens is if you don't invest time and effort into things, over time you'll start to slow down and eventually grind to a halt. So what can we do? So we want to aim for something like this, I think, where like you put a lot more effort up front and you're releasing slower, but eventually you're building a framework or a foundation to enable you to iterate on features really quickly. And I've seen this firsthand several times. So I'm going to delve into some specific examples. So after the Bake Off incident, the director of tech at the BBC made it very clear. He said, the iPlayer homepage never goes down. Like, I don't care what you do, but the homepage has to be up. So I was like, okay, so how do we do that? How do we ensure that without compromising our speed? Like, I don't want to give up the benefits of moving quickly and iterating quickly and continuous delivery. All these things that we were doing, I didn't want to sacrifice that for stability. So what we came up with was, and it's not rocket science, but we had Varnish in front, but we enabled a stale while revalidate mode, which is basically we would keep a stale copy of the homepage on any page for a period of time. I don't know if anyone's used Varnish, but we created a Varnish mod that would enable you to customize how long it would be kept. So you could send back a response header, and Varnish would store it stale for that period of time. And what that meant was that we could deploy all our different node microservices in the background and break things. But Varnish would have a stale copy, and the iPlayer homepage would be up, and everybody would be happy. We obviously would be reacting and fixing these problems, but at least the customers weren't impacted. So I think that was probably the single most important thing that we did off the back of that incident. Another thing we learned about, which is, I think it's common knowledge now, but at the time I don't think, there's only Netflix really who were sort of banging the drum of circuit breakers. For those of you who don't know, circuit breakers are things that are trying to protect services. So once you start developing microservices, there's lots of HTTP requests going back and forth. And if one service breaks, what you don't want to do is have another service hammer it with more requests. Because typically, if it's totally broken, the load balancer will return a response very quickly, and then the microservice will retry, or a user will get an error and they'll refresh. So very quickly, you get this huge cascading failure where one microservice will go down and then the rest will tumble. So circuit breakers are a way of controlling that, where if you get a certain number of errors in a certain time period, it will trip the circuit, and then any requests after that will just fail. They won't even talk to a downstream service. It will just fail. And after a certain period of time, it will go into a half-open state where it will try 1 or 2 tentative requests. And if they're successful, we assume the service is back. It will close the circuit, happy days. And if they fail, we'll assume it's still down, and we go back to an open state. Like I say, these are well understood concepts now. However, if you've not read this book, I would recommend it. It's got everything about circuit breakers, bulkheads, other techniques you can use if you're building a performance system. There is a second edition, which looks slightly more HD, but I think it's coming out at the end of the year. So if you've not read it, definitely go and read it. And now I've got some hopefully useful bits of tech that you can take away. So we found the Node sort of tooling for the things I've just spoken about kind of lacking. Like we wanted to use circuit breakers, we wanted caching, like we don't want to make the same request if we've just made it, retries, things like that. So the BBC made a library called flashart, which is, I think it's described as request with batteries included. So it's like a standard Node request module, but we add caching, circuit breakers, retries, logging, monitoring using statsd. It's all optional. And you would use it like this. We tried to use things that were standard. So we use capbox for caching. We use statsd for monitoring and things like that. It's all optional. So you know, this example here would retry 10 times, waiting half a second between attempts. And then if you got 200 errors, it would trip the circuit, and then it would retry after a certain amount of time. It's a very useful module. If you've not seen it, you should check it out. Another problem we faced is if you build an API, and if you build a good API, people will use it. So I've given an example here, a hypothetical example, which is if you build an API at Skyscanner for flights, maybe the website will use it. They want to display flights. Makes sense. Maybe the mobile app will use it in a different way. Maybe you want to do reporting, like how many flights do we have on offer at any time? That will call into the API. Maybe you want to do recommendations, personalized recommendations to the user. So that will start calling it. And then maybe you've got even companies external to Skyscanner who start wanting to display flights on their site. So the problem is, how do you, as the owner of a flights API, how do you deliver that API quickly without fear of breaking these clients? Which is what caused Dynamite to break the BBC, was that everyone was using it, no one knew how it was being used, so they eventually just got scared of changing it. So we don't want that. One technique we found useful was something called consumer contracts. It's a form of testing. So there is an upfront cost, so you're going to go slower initially. The difference between these tests and other like integration tests and acceptance tests is that consumers implement these tests. So maybe as part of your onboarding process of a new API consumer, you have a stage where you say, you have to provide us with a consumer contract. So how are you going to use our API? What endpoints will you call? What will you expect in return? And these contracts are loose in that they won't be, you won't explicitly state what you expect, just like I expect certain properties and I need a certain value to be in that property. As loose as possible and no more. But then the producer of the API will execute these tests. So the producer guarantees that if you provide me with these contracts, I will run them and I will not deploy a broken version or a version that will break your client application. And typically you would do something like this. So you would build, run your normal tests, deploy to some sort of staging environment maybe, and then you'd run the contracts. And if they fail, you can go back and fix them. And if not, you can deploy safely. There's also a Node module for that, which we made. It's open source, and it looks something like this. Again, it builds on other open source projects. So you would say, here's a user API test. I am a GitHub service. That could be mobile app, website, whatever. I expect to be able to make a GET request to this URL. And in the response, I expect a 200 with login name and public repos, 2 strings and an integer, and that's it. It also comes with a binary you can run that will execute all the tests in a contracts folder, which you can integrate into your continuous delivery pipeline. So yeah, again, if you've not seen that, I'll go and check it out. It's not for everyone, but we found it really useful. And we used it internally with communication between our microservices as well, so that we knew we weren't breaking anyone when we deployed. So I'm more of a back-end developer than a front-end developer. I've only started dabbling. But I think React kind of echoes this same thing, which is like hey. Okay, so React is kind of similar, where it asks you to think about things up front. So you have to think about the components in your system. You have to think about how they interact with each other, and you have to think about where the state should live. Which, if you're hacking on jQuery, you don't have to think about. You can just start hacking, and it's much quicker to get going. But the benefits of React are that once you've got these reusable components, you can build something totally new very quickly. We have something at Skyscanner called Backpack, which is a series of React components. It's kind of like Bootstrap, I guess, in that respect, based on atomic design principles. I don't know what that is, but go and check it out. I'm more back-end than front-end, so yeah, let me off. And finally, we have something called MShell, which is an automation toolkit. And I think that MShell is it's basically codified my lessons over the last 5 years. From that moment where I broke iPlayer, and I was crying because it was down for a week, to now, all these things I've just spoken about, MShell just does for you. Like if you want to create a new microservice, you type a nice command line. It creates a node microservice that will have monitoring. It has tracing using X-ray. It will have Dockerized builds. And yeah, so the idea is that you can take an idea to production in an afternoon, and I think every company should strive to build something like this. And that was it.